Welcome to Easy Go YouTube channel. Today we are going to discuss about disk scheduling. Before we discussed about how the memory stores in the secondary memory, how we can access the data from the secondary memory. We got to know. Today we'll get to know about different types of disk scheduling algorithms. So before knowing the different types of disk scheduling algorithms, first we need to know what is disk scheduling. So here the operating system is responsible for using hardware efficiently for the disk drives. This means having a fast access time and disk bandwidth. So what here it is telling is, here the user access the data from the secondary storage. I already mentioned the secondary storage stores the data in the form of disks, where each disk consists of tracks, where each track consists of sector, where each sector consists of a data. So with the help of read write head, we'll access the data from the sector. So according to user desired data, we'll access the data with the help of read write head. So this is called as disk scheduling. According to the user's requirement of data, will access the data from the secondary storage from the sector which stores the data. So in this we are having access time. Access time has a two major components in this. One is seek time and other is rotational latency. Seek time is a time for the disk or to move the heads to the cylinder containing the desired sector. What is meant by seek time means it is the time required for the read write head to access the data from the sector. And what is rotational latency? Rotational latency is the amount of time it is taking to access the data from the desired sector. It is called as rotational latency. So what is a disk bandwidth? Disk bandwidth is a total number of bytes transferred divided by the total time between the first request for the service and the completion of the last transfer. Okay. Now let us know the different types of disk scheduling algorithms. So the first one is first come and first serve algorithm. So in this we'll be having a, let us consider we have 200 platters which are arranged in platters which are arranged in a secondary storage. In this we need to access the data which are access the data which are stored in the sector, which are stored in the sector in the form of ready queue. So the read write head first, um, it starts at 53 as mentioned in the diagram, as it's showing in the diagram. um, the read write head initial state is at 53. So how it how we serve the users access user requirement of data. For it serves the data according to user requirement. Whatever user access the data, it tells that whichever process comes first, it serves first. Okay. So let us assume that the read write head is first pointing to pointing to a 53 uh, 53 data. So after 53, which is the next process, which is the next process in the queue. It is 98. Okay, it is 98. So um, it starts serving to 98 process. Then next it serves whatever so according to queue, whatever comes first to the queue, it will read write head serves the data to the user according to the whichever arrives first in the queue. Okay, okay. The next comes is 183. So from 98 it serves to 183. Then next is serves 37, which comes after 183. Then next it serves 122, which comes after 37. uh, then next it serves 14, which comes after 144. Then next it serves 124, which comes after 14. Then next it serves 65. 65, 65, which comes after 124. Then next it serves 67, which comes after 67 65. Okay, what is first come first serve tells is whichever process comes first, it will be served first. So the main motto of this FCFS is whichever process comes first, whichever process present in a ready queue will be served first, will be executed first. Okay, okay. So here the total head movements of cylinders are, so we need to subtract in order to know the head movement of the read write head. Okay, in order to how the read write head access the data from the secondary storage. Okay, so in order to know, we need to subtract the larger number, how the way how it serves, how the read write head serves the data to the user. So in order to know it, uh, we need to subtract the larger number here, how it serves. So here the 183 is the largest number, so 183 gets subtracted from 53. So 183 minus 53 plus 30 183 minus 37 plus 122 minus 37 plus uh, 53 50 sorry 122 minus 37 plus 14 plus 122 minus 14, again 124 minus 14 plus 67 minus 65. So after subtracting all the terms, you will get this answer 64 cylinders. Okay, okay. So next we'll learn about shortest seek time first. So shortest seek time first tells us about whichever initially it starts wherever the read write head points at the platter, wherever it initial state will be same, not the same, wherever the read write head points, it starts initial state will be wherever the read write head points, and the it serves according to the whichever which it serves the process whichever has the shortest um, time. Okay, let us consider here after 53, whichever process is having a less which is nearer by to the 53. So nearby process for 53 will be 65 and 67. So what it tells is what it tells is whichever process have a least whichever process is having shortest seek time will be served first. Okay. Okay, so the read write head initial state is 53 here. So which is closer to 53 will be served first. So here the process 65 and 67 are closer to 53. So 65 and 67 are served first. Okay, and then um, 65 and 67 is served first. Then later um, 37 is served. So it started from 53. Since 65 and 67 are closer, it served first. Then later it served 37, which is closer to 53. Then it served to from 37 it served to 14, which is closer to 37. Then it served to 98. 98. Then after 98 it served to 122 and 122 and it served to 124 as well. Then later it served to 183. So after subtracting all the terms, we'll be getting a desired value of the head moment. So this is called as the shortest seek time first. Okay. So next we'll learn about a scan. It is also known as elevator. So here the disk arm starts at one end of the disk and moves towards the other end, servicing request until it gets to other end of the disk, where the head movement is reversed and servicing continues, sometimes called the elevator algorithm. Here the illustration shows total head movement of 208 cylinders. Now let us see how the scan works out. Okay. So here initial read write head points at 53. Then scan tells us from 53 scan algorithm tells us from the initial state the read write head goes to the starting position of the platter. So, starting position of the platter, uh, in between it serves whichever process in bit from 53 it goes to 0. During this time it serves whichever process comes in between. So from 53 37 and 14 comes in between, so it serves from 53 to 37 and 37 to 14. Then from 0 it reverse again and serve to rest other processes. So here it serves 65 and 67, 65 and 67. Then later it serves to 98, then 122, then 124, then 183, as 183 at last. Okay, this is the scan algorithm. After subtracting all the terms head movements, we'll get this value 208 after subtracting all the terms, sorry, all the all the movements of the read write head, that is which are there in the ready queue. After serving all the processes, after subtracting subtracting that the numbers, you will be getting the 208 value. Okay. Okay, next we'll get to know about C scan. C scan is also called as a circular scan. In this, the head moves from one end of the disk to another, servicing request as it goes. When it reaches the other end, however, it immediately returns to the beginning of the disk without servicing any request on the return trip. Treat the cylinders as a circular list that wraps around from the last cylinder to the first one. So let us know about the circular scan. It is similar to the scan algorithm. The initial state will be a same. The read write head points to the 53. Then, but the here the slight change is in scan algorithm it moves to zero. It moves to zero. Here, from 53, it moves to higher range. That is that is it moves to 199. Okay, the read write head moves to 199 platter here. Okay, in order to access the data between during the movement, whichever process comes in between, it serves to the processes. Okay, so here it starts from 53, then it goes to 199 till last it goes to 199. In between, it serves the processes. Du- uh, uh, During the time duration from 53 to 199, while it's serving, it come across different processes like 65, 67, 98, 122, 124. Okay, so whichever process comes in between, it serves uh, during it goes from 53 to 199. Okay, then after reaching to the point of 199, then again it reverses, then it again goes to 0. That is starting state 0. From 0, it serves to the other processes which are left out. Okay, so from 0, the 14th process was left out, so it served. And again from 14 it serves to 37. Like this, C scan algorithm works out. Okay, now next we will see C look algorithm. C look algorithm. Here arm only goes as far as the last required in each direction, then reverse the direction immediately without first going all the way to the end of the disk. So let us see what is C look. Same like all algorithms, the read write head points at 53. So, 53. Then from then it serves. So unlike a C scan, it doesn't go. The read write head doesn't go to the last upper bound. It in here it serves from 53. It serves whatever process comes in between from lower bound to upper bound, from 53 to 183. Whichever process comes in between 53 and 183, it serves. Okay, okay. So here 183, here it doesn't go till last 199. It stops here whichever the maximum value comes. So here the maximum value is 183, and the lower value is not the lower value. It is the initial state of the read write head, where the read write head points in order to access the data from the sector. So um, 53 will be the assumed as 53 will be the read write head start, read write head starting position. So from 53 it serves to 65 process, and 65 it serves to 67, then 98, then 122, then 124 will be served, then 183 will be served. Unlike C scan algorithm, it doesn't go to 199. It stops. It doesn't go to 199. It stops at wherever there is a maximum range of value, unless going to the last point at 199. It stops at 183. as mentioned in the diagram. See here, points here. Then from 183 it doesn't go to 0, unlike like C scan algorithm. It doesn't go to starting state, that is 0. It doesn't go to starting state, but from 183 it directly serves to 14th process, whichever whichever is the minimum one. So from 183 it serves to the minimum request, which is having a minimum request to the process. Then it serves to 37. Okay, so after subtracting all the terms, all the values, we'll get the read write head movement. Okay, so So then next we have look algorithm. It is similar to the C look algorithm, but there is a slight change in a C look look algorithm. What it is means, it is same like C look algorithm, but at while during it reverses from 183. It serves first to 37, then 14, unless like serving to lowest number 14 and 37, then after going 37, the 37 it serves first 37, then 14. So uh, the limitations of C scan sorry, the C look is improvised in a look algorithm. Okay, okay, thank you for watching this video. I'll get back with another video. Okay, thank you.